we can't use the Pythagorean theorem without right triangles. So because they're right triangles, we can figure out the length of the third sides to say that, yeah, those two triangles are in fact congruent because the third sides have to be the same. So what we're going to be learning now is that if you have a right triangle and the hypotenuses are the same and one pair of legs is the same, that means the triangles have to be congruent because you could end up using the Pythagorean theorem with side, side to prove that the triangles are congruent. However, there's a shorter way to talk about it. Right here says theorem 4.8, the hypotenuse leg theorem. So this basically means this is giving us some information here where we no longer have to use the Pythagorean theorem. Okay, I think it's Mr. Rixick's chemistry class. Okay, so this basically is saying, because we could use the Pythagorean theorem here to prove that the third sides are the same to use side, side, we don't actually need to do that every single time. We can just say the triangles are congruent if the hypotenuses are congruent and a pair of legs are congruent, as long as you have a right triangle. That's what that's saying. And this is called the HL theorem for hypotenuse leg. The only type of triangle that has a hypotenuse is a right triangle. So if you're using HL, you can only use it with right triangles. We'll make that really clear. You can only use it with right triangles. Okay, turn the page. We have like one more example and then we're done. This is a very short lesson today. So let's have ourselves a look here. Ashton or Buddy, he's washing some windows using a 10-foot ladder. And the ladder reaches the first window right here when he places it as shown. And you'll notice what kind of triangle it forms with the house when the ladder leans up against it. The next window, this one right here, that's the next window, is the same distance above the ground as that one. You can see they're the same height above the ground. Where should Aston place the foot of the ladder in order to reach the next window? In the same spot. Yeah, why? Yeah, because if we're talking about a right triangle here. So here's the ladder, 10 feet. There's that. This point here, that's the first window. And then if he's going to do this again, he's going to use the same ladder. Here's 10 feet. And here's the second window. So he's going to move the ladder from here over to here to put it by the second window. Now, what does it tell us about the next window in terms of its distance from the ground to the first window? What's that? I think it does, though. It doesn't give us a number, but what does it say? Yeah, it says right here, the next window is the same distance above the ground as the first window. So we don't know how high above the ground it is. We don't need to, but we do know that they're the same. And we know that 10 feet is the same as 10 feet. So the distance across the ground has to be the same distance across the ground because we have a right triangle. We have a congruent hypotenuse between the two, and we have a congruent leg between the two, which means that the distance from the ladder to the house along the ground has to be the same as well. So let's just say by HL, he should place the ladder the same distance as the first window. There we go. However far away the ladder is from the house needs to be the same for the second window because all the measurements are the same between the two. That's basically what we're saying. And if this was 5 minutes ago, we would have had to use the Pythagorean theorem again, but now we don't have to because now we have HL, so we don't have to go through that process of doing the Pythagorean theorem again. Okay. So we got one more problem just down at the bottom here, and then that's it for the notes, and you'll have about 40 or so minutes of work time today. So lots of time to get work done today. So if you are missing work, or if you are missing test corrections or tests or anything like that, you will have lots of time to work on those things today. So here we go. Number 2, what information is needed in order to apply the hypotenuse leg theorem here? So first of all, let's go ahead and figure out what parts of these triangles actually correspond to one another. Probably be easiest to start with what? What letter is going to be easiest to match up here? Yeah, Q and M, because those are where the right angles are. So we're saying P and L. I would agree with that. So P corresponds to L. All right. What? Dried highlighter on me. Okay, what is it? N and R, right? Yeah, those are the only other ones. So N corresponds to R. Okay. So if we are going to use HL here, what do we have to show? We already have a right angle, right? Okay. So the right triangle portion of this is good to go. So what part of the triangle is LN here? Is that a leg or is that the hypotenuse? That's the hypotenuse. So PR would need to be 9, right? So first thing that needs to happen, PR equals 9. What information is needed? We need to know that PR equals 9. What other piece of information do we need to know to use HL here? Yeah, that MN is equal to 5. Good. Those two things would be enough to use HL, because if the hypotenuses are the same and the corresponding legs are the same length, then the triangles are the same size. So if those things are true, so let's say if PR equals 9 and MN equals 5, then triangle, give me 3 letters from the first triangle. LMN, okay. If we write it in that order, that means it's congruent to triangle what? Good. Triangle P, Q, R. So that's what we would be using. If PR is equal to 9 and MN is equal to 5, that means that the two triangles are congruent by HL. Cool. So that was the entire lesson. Very short.